And Shiploinks. Oh, guess what I forgot? Okay, you're saying hi this time.
Hello everyone, we should be live now, and this is Arya's stream. This is the IDGQD sound channel, and Arya is getting his iPad, I think, maybe, or whatever else he needs to do to set up. Hello.
Hello. Oh, an error occurred.
Well, yeah, I'm not even sure that we are streaming, but I introduced the channel and I got things going.
That is interesting. That's never happened to me before. I'm just, come on, one time for Big Daddy. One time for, it says the stream is already an hour long. Well, that's just weird. Okay, maybe we are now live. Hello, if we are live. How do you, who do you, where do you, how do you?
And these are the people who will try to give you technical advice on how to program.
Okay. Are we live? Looks like we are live.
On my side, I don't see anything.
On my side, I see right now that we are live, but I'm not sure if it's current. Did you just get it?
I see something now.
Okay.
I see everything. We are live now.
All right.
Say hello.
Hello, everybody. Sorry if you've been here for a minute or two and it's been weird. It's been weird for us too. But this is part 5 of JSFX Scripting. So we've come a long way in just 4 weeks. At least in my perception, it's further than I ever thought I would get, really. So yeah, so it's been really cool, and it's all thanks to this guy above me.
You put me above you? Hello, Arya. It's great to be here. Thanks for having me over. In case you all don't know me, I am Leandro Facchinetti. I also have a YouTube channel, and I also do live streams, mostly about coding, sometimes, like tomorrow, about music production. And that's what I do. I write code for a living.
That is a pretty awesome life, I would say. I mean, I'm sure it has its annoying parts where you have to rename a bunch of things for a day and a half, but it's fun.
I mean, it's also nice. I like it a lot. Of course, there are things that are not great about it, but even the renaming part, even the more tedious tasks can be kind of interesting, especially if you try to come up with ways to automate the tasks. Usually that takes more time than doing the task, but it's more fun too.
Mm-hmm. And I think it's like, yeah, that's one thing that really gets me addicted to ReaFIR. Like, I spent so long like working out like a Foley recording workflow, and then I usually, like do one Foley session, then I won't do another Foley session for a while, and then the next time I come to it, it's not like I pull up that workflow. I pull up that workflow and I realize like there's a bunch of new stuff I learned, so let's put those into the workflow. And then again, maybe with that new workflow, I spent like one session on it, and you're constantly like updating, and it's very addictive. I like doing that.
Yeah. Yes, it's a great way to procrastinate.
Yeah. Bobs NY, hi Bobs NY, says that we are a bit glitchy, like jumpy, like that, or more like there's a delay.
That was said when we were trying to figure out if we were streaming or not.
Oh, word. Okay, so hopefully it's all okay now. Let us know, Bobs, if everything is Gucci now. And so, Leandro, I've been busy. I've been doing a bunch of things with some degrees of success. And I'm trying to kind of like have a working version, which is this, and then I go to my other versions and I get weird with it. So we have one version like this, which I'll show you actually afterwards. But one of my homeworks was to figure out what method I like the most for generating the bit masks. And why am I opening a WordPad? I'll just open this. So what I went with was the $tilde situation. But honestly, what I wish I could do, and I know you can do this in Lua. Somebody, the awesome Tormi Van Cool helped me figure out how to do that in Lua, where just when it comes to the sliders, I wish I could just generate it using binaries. So now, we're up to 17 sliders. I wish I could go like, I want slider 17 on, slider 16 off, 15 off, 14 off, 13 on, 12 on, etc., etc. I wish I could just generate that. And so in Lua, it's the toNumber function, and here that doesn't work. So what I went with was this situation, which is pretty simple. And I guess it led me to kind of design the slider structure in a way that I would never need to do really complex stuff with it. So I would never need to have like 17, 14, 9, 8, and 3 to 1 on. So the system worked. It's fine, but I wish that you could do that with binary, which maybe you'll tell me right now it is.
I am not sure. If I were to try to do that, I guess I would represent a number in binary using a string. And I know that in JSFX there are a few functions, not a lot of them, just a few functions to manipulate strings. One of which may recognize numbers in binary. So I'm gonna go check the documentation for that real quick, and we can figure this out. So what I'm doing, in case you are interested, is I'm going to the JSFX programming page on the ReaFIR website, and the whole language, all the things you can do in JSFX is documented here, including a section about string functions. And I'm looking for something that goes along the lines of string match. We looked at string matching in Lua, and I believe there is something similar for JSFX, and in fact there is. It's called match.
Match, okay.
Yes, and it seems like you can match on numbers, but you cannot match on numbers in binary. You can only match numbers in decimal.
Okay.
So if you really wanted to go that route, another thing you could try to do is represent the number in decimal. So you would come up with a number that is like 10,000. And then you can write some code that transforms a number in decimal and interpret that number as binary. So we would write some mathematical functions that do division and multiplication, addition, and so forth, and would convert a number that is in binary but represented in decimal into its real decimal representation. For instance, the number 10 would be written like 10, but we would do some arithmetic to it to figure that this 10 actually represents the number 2.
Oh, and
100 represents the number 4, and so on.
And is that by basically going, the old first digit times 2 to the power of 0, second digit 2 to the power of 1, third digit 2 to the power of 2, then add all of these together kind of deal?
Yes.
Oh, cool.
Yes, that's one way of doing it.
Okay.
Yes.
I would like to learn to do that, but for this plugin, at least, we don't need to anymore. And maybe I can make that my homework to figure that out. Because I did think about it, but I was like, maybe there's a better way. I don't want to look ridiculous writing binary math.
Yeah. My favorite? I assigned you a homework to come up with your favorite way of representing this. And I want to share my favorite way, because it's not the same. But first I want to learn why that is your favorite way. I mean, I'm not trying to just teach how to write stuff so that it works. I'm also trying to have these conversations about preferences, and there is no right or wrong. It's just a matter of what you believe in, and I want to learn more about you. So why do you prefer this option?
So basically a couple of reasons. So the first reason is, and it could be that I didn't fully understand the other system, this sign. I was having to play with this one, and from what I gathered, it's like, it's been a while, and again, don't code when you're high, kids. But I just saw something about it that I didn't understand, where it seems to, let me see if I can recreate the thing that was confusing me about it. Yeah, so it's like, does it just find the bigger number of these two? Okay, yeah.
No, it interprets the numbers as binaries. So the number 10 is not really the pipe operator, the OR binary operator, the bitwise OR operator, does not look at the number as 10. It looks at the number as 10 in binary, which is, what is it? It's 8 plus 2. So it looks at the number as 1010.
Okay.
Or 110. I think it's 110. Yeah, whatever. It looks at the number in binary. And it does the same with 42. So it looks at 42 in binary. So it's a sequence of ones and zeros. And then it does the OR operation bit by bit. And it seems like all the ones in 42 are also ones in 10. So when you OR the two together, it doesn't change. It stays 42. That's what's going on. But since you find this confusing, forget about it. It's a way that doesn't work for you, so that's fine. Just forget about it. Don't use it. Let's use the other way. And you seem to... hey, Bo.
Hello, Bo.
It's going well.
Bo, I'm really happy for you because Chris from Air Windows did his Hall EQ, and it actually sounds really nice. And it got me wondering if that could work as a really good auto declicker, or at least click minimizer, because of the way it works, and because clicks are sudden, quick irregularities that don't overall affect the trend of the audio wave file. So I really want to have a play with that. So you really got what you wished for there, Bo.
Yeah, and I was reading the chat after the stream that we did together on my channel, and I couldn't read the chat because I was streaming from my I was using my streaming computer to also do the ReaFIR stuff, and it was a crazy audio routing situation. But I reread the chat after the stream, and I kind of like the idea of trying to convert one of the Air Windows plugins into JSFX. I think it was Fozzie's and Stuff's idea to do that, and I think we are going to try to do it at some point.
Let's do it. Yeah.
I want to learn more. I know JSFX a little, and I know very little about digital signal processing. So I want to learn more about digital signal processing by looking at someone else's code, and I want to learn more about how to do VSTs and audio units in C.
Awesome.
Which is something that I know nothing about. So I think it could be fun to do that. And I looked at the source of some of his plugins, and it's mostly straightforward. I mean, some of the mathematics goes over my head, but if you look at the C and C++, it kind of makes sense. It is basically C. There is very little C++ in there, and I think it would be nice to convert it to JSFX as an exercise.
Yeah, I mean, count me in, and we can even ask Chris for his blessing, and obviously give him all the credit. But yeah, I thought of the same thing. Bo says, whoa, why do I sometimes get my own audio in my head? Oh, what the hell? Is this what it is? Yeah, shut up, Arya. Okay. Sorry. So yeah, this system, sorry, what were you saying earlier about this system? Maybe you were going to say something?
No, I was interested in knowing why you prefer this version.
Just because for me, like at least in this case, it was useful to kind of visualize it. So with this way, I could go like, if I wanted to write a number, like I would just kind of visualize it and go through it one by one. So I would like first generate a $, tilde, two, and then I would just nudge it over 6 times, right? And then I would add to that, another one of these bad boys. I would like to, for this to be shortened, the $, tilde, to something like 1 character, but that's just a ReaFIR brain talking, and then +1. And I think, whoop-itty-doo. And I think that would be the same as this.
Yes.
Yeah. So I just thought, it would be like kind of visual, and maybe it's like a little awkward to read. But at least for this plugin, I thought, okay, like I needed to generate basically 4 sets of sliders. So I wrote some variables for them, and I just set those in a difficulty. And then as soon as I wrote the whole thing, obviously I added a bunch of stuff. So then just on top of those, I'm also adding a couple of things to where I need to call for those variables to do the bit masking. Because once I got the ball rolling, I thought, it'd be cool if there was like a difficulty curve within each difficulty that makes it harder or easier inside that difficulty. And if you remember, we had this issue of us like updating the parameters to generate a new question, but that actually not doing anything. And I did a bunch of testing, and basically from what I gather, if you change a slider and you're not in the slider block, it just keeps going. It even visually changes it, but somehow it just doesn't go back to the slider block. So I thought... Yeah. And I thought one easy way to just fix that real quick and dirty is that before what we did was we generated a question, then the answer was revealed, and then 5 seconds later it was reset. This time it just tells you to wait, and then you can click on go to regenerate a new question, and then it generates a new question. Because the user changes the slider, it gets communicated and it kind of goes back to the top of the code.
That is a nice solution for this. When we encountered this problem the first time, I thought of a different solution, which was to extract the part that does the resetting, that comes up with a new question. Extract that into a function that would be called when we need it. So it will be called 5 seconds later, for instance. And that would be a way for you to learn how to define custom functions. We know sort of how to do that in Lua. We used it a couple times, but we didn't use any custom functions, any user-defined functions in JSFX. We are calling functions that come with ReaFIR, like slider show, but we are not creating our own, which is possible. Like the UI setup function you're calling in your code is a user-defined function. It happens to have been defined by a library that you are using, but it is defined by that developer, not by ReaFIR. So that's another way of doing this. You can just extract this into a function and call it in multiple places. But your idea is also nice. You are not just showing the answer for 5 seconds. You're giving the user as much time as the user wants to appreciate the answer.
I did try with the functions, and it was a while ago, so I don't remember exactly what happened. I may have done it wrong, but basically I like found the function on another JSFX. I copied it over. I did some stuff to it, but I couldn't exactly crack it. And I do actually call that thing that you created in a few places, so a function would be a good thing. Because I also thought, okay, what if there was a point system? So now there's also a point system where if you get the answer correctly, you get an extra point and the total number of questions goes up. If you get a question wrong, just the total number of question goes up. And for this to work, again, I needed to do this time thing. So we definitely have this bit of code that we use a few times. So we can make that a function. And then I gotta kind of figure out a way to show the points to the user. So the point system works here, but we'll show it to the user as well.
I mean, you can always have a slider for that.
Yeah, well, okay, so again, if you have a slider for that, I tried and it wasn't working because, again, I was trying to kind of like go, just go really line by line and see what happens. And I think basically when you change a slider value, once you enter, once you enter like the block and sample blocks, it sometimes just keeps going. Because whatever that was true that was setting the answer remains true. So it keeps counting up. Yeah. So I don't know. Let's look at this stuff.
Couple things that I want to talk about. The first is I'm going to backtrack and talk about my favorite version of that code that sets the mask. And then we can talk about what Bo is saying in the chat that is super interesting and has to do with the declicker and the hole filter. And then we can talk about your question about why things are running in ways that you don't expect. So let's start with my point of my favorite version. So first of all, I want to reiterate, there is nothing wrong about your preferred version, right? It is short. And if you know the magic of $tilde, it's pretty straightforward what you're doing and how you're creating the binary number that way. It makes a lot of sense, and I like it, and it's short. My preferred version, if I was going to write this myself, would be to have something more high level. The way I would do it would probably be a function, one of those user-defined functions. The function would take as argument the slider number, like 16. And the function, and also what I want to do with a slider, if I want to turn it on, off, or toggle. The function would calculate the mask for me. And I would have to call the function 17 times if I wanted to change all the 17 sliders. And I would call it with like my slider show function, slider 1, show, my slider show function, slider 2, hide, and so on. Why do I like this better? I think it's more readable for people who are not initiated, who don't understand the $tilde, that they are just going to see slider, my slider show, slider 2, hide. Okay, you know what I mean? You don't have to be trained to understand what's going on. The upside of this is that it's more readable. The downside is that I'm going to have a lot more code on the screen, and I'm not going to do everything in one operation. I won't be able to just say slider show with a mask and then show all the sliders that I want with one invocation. So probably it's going to be slower in my way, but I don't think it would be noticeable, so that's fine. So, and how do I even compute this? Like, given the number 16, how do I compute a mask for slider 16? It's actually rather, I think it's straightforward. I think it's 2 to the power of the slider number. I think that's the number. I think that's the mask. Oh, actually, you have to subtract 1. So it is 2 to the power of slider 16 minus 1 quantity. That's what it needs to do. Because sliders start with the number 1. So that's why. And the mask starts with 2 to the 0.
Cool.
So there you go. That would be my version. And it's not better. It's not worse. It's a different trade-off. And that's the trade-off I would make. I always try to optimize for readability first.
Yeah.
Then for conciseness and for performance and all these other considerations come second.
I did think about this because you were also saying, like think of the user base. And I guess the user will get here and they'll be like, what the hell is this? And it's not, it's not super native readable even when you do know what it does. Like, even when you do know what it does, you can't just, at least I can't just glance at it and be like, oh, that's the situation. It's more like, okay, so that does that, and then you go in, it's a little bit
It depends on who's the reader.
Yeah.
So I kept saying that I'm optimizing for readability, but readability depends on the reader. I mean, if you find text written in Hindi, you're gonna say, "Oh, this is not readable." But for people who are born and raised in India, it's going to be like, "Okay, I can read this. It makes a lot of sense." So readability is a conversation with the reader, and it depends a lot on who is the reader that you have in mind. What I find with most JSFX that I find in the wild, they are written for the initiated, for people who know the DSP, digital signal processing, for people who have been programming in C for a while. And I am not like that. So when I write JSFX, it comes out a lot different, and there is no better or worse. It's just a different trade-off. When I'm writing for people who are like me, who are trained in things like programming language theory, web design, that sort of thing. So my code ends up looking different, and in some ways behaving different as well. In some cases, my code may be slower, or my code may be easier in some ways to the user. For instance, I tend to steer away from terms when I am making up a label for a slider. I try not to call it like RMS size. If you go to the ReaComp compressor, there is a slider that reads RMS size. I know what that is, but I think I prefer to call that the reaction time. That makes more sense. That's how much time the compressor is going to take to react to the thing. And I even put in parentheses like RMS size in parentheses for people who know what that means. But if you go to my auto mixer effect, you'll see a slider that is called reaction time in parentheses RMS size, something like that. So there you go. That's the spiel.
I think since we are doing this for the sake of education, let's try to do that function, or at least let's try to do a function. Maybe we can also do that time of guess situation as a function as well.
We already spent a whole stream just writing binary masses. I'm sure that functions will come up again in the near future. We can write a function then. You already have something that both works and satisfies you, so that's enough. I'm okay with that.
So yeah, I guess I'll show you basically what we got so far. So right now we have a fully functional easy mode.
Before you show me, I want to comment on what Bo was saying in the chat, and I also want to try to explain the execution model of JSFX to try to clarify some of your questions about why some things are running or not running when they think they should have been. So Bo is saying that he has a different idea for a declicker, and I'm interested in hearing more about this because declicking is something that I also have in mind. I mean, I have been trying, and not really trying, but I have this idea that I want to replace the basic things in Rx from Isotope. I want to replace that with my own JS effects because Rx can be kind of expensive, and I only use the basic stuff, and I'm like, I think that I can try to recreate this. It probably is not that hard. And the declicker is one of the things that I like the most about Rx. And as far as I understand, a click is just a sudden change in the samples. So if we do something that is maybe a super high cutoff frequency on a low pass filter, it's going to let through most things. But if your samples jump too far apart, then I limit that jump. Maybe that's the idea that Bo has, and I have this crazy idea. I don't know if that's how you do a declicker. Maybe it is the standard algorithm for doing a declicker. I know very little about declickers, but I'm interested in knowing because I have this project that I'm going to work on at some point to replace the basic functionality of Rx with JSFX.
That would be lovely. One thing I know from RX, just from having used RX, I mean, even this month I've been declicking this entire audiobook, and it takes a long time, and so I feel like there is a way to automate it. Namely, right now the RX declick is using the human's brain to identify the click, and we identify the click usually by scrubbing the audio. So if there was a way to teach the machine how to scrub the audio, then the machine would know, because you can't put the declicker on the whole track, otherwise you'll get a lot of artifacts. So we are just going through and kind of like scrubbing. So if there was a program that scrubbed and then found this specific sound that anybody can hear and identify, that would be awesome. And RX at least claims I mean, I'm sure they're not lying that they use machine learning to make the declicker work, and it does work super intelligently sometimes. Like sometimes if you say a word like clap or something with ST and L all together, so hustler, right? You get these series of clicks, but RX knows which ones are clicks and which ones are the consonants from hustler, like hustler. It's very cool.
Yeah, I mean, when people say like it's machine learning, everyone is like, ooh, crazy technology. But it's not that hard. I mean, it is crazy mathematics, but the implementation is not that crazy. And most machine learning algorithms have been packaged in very easy to use packages like ML5. I think that's what it's called, ML5 from the P5 people. Is that what it's called? Yes, ML5JS. So there are all these crazy algorithms packaged in very neat packages. You can just go ahead and use the algorithms. And I had ideas like this too. So maybe if I could look at the spectrogram of some audio, I could detect pops and I could do a depopper that way. I was like, ooh, that could be interesting. But I never actually did it. So it's a plan for future streams, maybe.
Very cool. This is the one?
Yeah, that's the one I was thinking about, but it's just one. There are plenty of packages like this for machine learning. I mean, machine learning is new and crazy and exciting, but it's not inaccessible. That's what I'm trying to say, I guess.
Cool.
Yeah, and I'm also interested in the whole filter and how that worked in JSFX and also in C by Chris from Air Windows. And it seems like this idea of the clicking is something that the de-esser, the dbes, I guess that's what it's called, the Air Windows de-esser.
I've been looking for that one actually because you mentioned it.
So maybe that's the principle behind that de-esser. It looks at, oh, this sample is very different from the one before. I mean, too different. Let's make it not as different. And then you can prevent S's maybe. That's kind of interesting. But yeah, all nice ideas. Now, do you want to go over the execution model of a JSFX, or at least my understanding of it? So the way I came up with this explanation is I wrote a JSFX that would be just a bunch of blocks. So I would have the init block, the sample block, the GFX block, and so forth. I would have all of these blocks, and I had those debug variables +1. You know what I mean? We did this in a previous episode. That's a simple way, a sentinel. It's just a simple way of detecting whether that block ran. And here is the explanation that I can give you. To the best of my knowledge, this is how JSFX work. You load the JSFX into the track, either because you put it on the track, or because you hit play, or because you had the effect bypassed and you unbypass it, whatever the case may be. You start the execution of the JSFX. First thing is going to run init. That's the first block. If you have it, all blocks are optional. In fact, just a blank file with nothing in it, it's a valid JSFX that doesn't do anything. It's a bypass. So all blocks are optional. That's kind of interesting. Okay, so first the init blocks runs. Then the slider block runs. Then two things are going to happen kind of at the same time. It's going to start your graphical user interface if you have one. So if you have a GFX block, we have not talked about this in the stream, not together anyway, but you already know about this because I see you have some graphical user interfaces. You're even using a library for this. It's by, I don't know how to pronounce that name, Geraint stuff?
Yeah, Geraint Luff. Yeah.
Geraint Luff?
Yeah.
Okay. Yeah, so you're using that library for graphical user interfaces. So your graphical user interface starts. And at the same time, concurrently, your audio processing starts. So both of these are running at the same time. You cannot count on one running and then the other, or the other running and then the one. They're going to run at the same time, which is it's important that you know this, because in many cases, you want to show in the graphical user interface something that is related to the sound coming in. Maybe you are doing an oscilloscope, or you're doing a spectrum analyzer, or whatever. So your graphical user interface depends on the audio coming in. It's important to know that audio processing is going to happen while the graphical user interface is being rendered. So whatever computation you do, like maybe you compute what is the frequency of a certain sample when you want to show that in the graphical user interface. Your computation of the frequency and the showing of the computation will happen concurrently. So you have to be aware of that. If you try to compute something and you are in the middle of the computation, maybe your graphical user interface code will try to run, get that value in the middle of the computation and display something in the middle, and that will look glitchy. That happens in my auto mixer. If you're interested, I have a video in my channel in which I do a code review, and I explain how in the auto mixer I want to show the RMS, I want to show the power level of a channel, and I have to do the whole computation first, and then I update the variable that the graphical user interface will see. I have to use temporary variables to do the computation because of this concurrency that happens. So your graphical user interface is the @JSFX block, and your audio processing is it actually happens in 2 blocks. It happens in the block called block, the block. That one is called first. And then your sample block runs. And they don't even run the same number of times. So the init block is going to run only once after you hit play. So for instance, when you're done with the project and you start rendering the project, the init block is only going to run once. When you start the rendering, it's going to run, and then it's not going to run again for the rest of your project. So if you're rendering an audiobook of 17 hours, your JSFX in that track will run the init block only once.
What if you were to like use use automation or just manually, if you bypass and unbypass, the init block doesn't run again?
I think it will run again, but you would have to test. I don't know.
Okay.
I think that the slider block will run every time you change some parameter via automation. I'm pretty confident of that. If I remember correctly, the slider block will run only once if you have no automation, but if you do have automation, it will run several times. And then your GFX block will run about 30 times per second. That's the refresh rate of a graphical user interface in JSFX. I don't think it's running at 60 Hertz. I think it runs at 30 Hertz, if I remember correctly. But the point I'm making here that is very important is the init block runs infrequently. The slider block runs only when you run automation, but other than that, or when the effect is being loaded right after the init block. But it doesn't run that often. The GFX block runs a lot. It runs 30 times per second. If you do something slow there, you will notice. But the block runs a lot more often. I think it runs like thousands of times per second. And the sample block runs at your sample rate, 48,000 times per second, for instance. So that block is the one that runs the most. And another thing that I find interesting to know is the relationship between the block and the sample block. You may think that the block runs only when there is a block of audio ready to process, and that the sample block keeps running continuously, but that's not the case. Audio processing just doesn't happen that way, because 48,000 times a second, it's a lot of times a second. And your machine has to do everything else. It has to go to YouTube to upload the stream. It has to run your browser. It has to run OBS. It has a lot of other things to do. So the way it works is it gets a block of audio samples. It runs the block. And then it's going to set up a loop and run your sample block in a loop. It's just a convenience. The sample block is just a convenience. It's probably some performance optimizations as well, but it's just a convenience. When you're doing VSTs and audio units and you are writing audio processors in C and C++, there is no sample block. There's something similar to the block, but there's nothing similar to the sample block. And what most effects, like 99% of the effects, are going to do in the block is do a loop and loop over all the samples. So I think that what's going on here is just that Justin saw that and thought, well, why don't I give this guy some convenience block called sample that will pretend to run on every sample continuously. That's not really what's happening. It's an abstraction either way, but it's just a loop. So you could, in theory, do something equivalent in the block if you had access. I don't think you do. In JSFX, I don't think you have access to all the samples in the block at the block. I'm not sure. I don't think you have access to that. But if you had, you could simulate the sample block with a loop in the block. Does that make sense?
Yeah. There's also... So I'm dumb because I kind of overwrote some of the test code that I wrote by accident. And I will ask you a question about that too. But because when I was trying to figure out, well, like if we want to generate a new, if we want after 5 seconds to generate a new question, where should that go? And well, it couldn't go in the slider block fully because the user is doing something. We're already at the block. So I was looking for a way for these blocks to kind of communicate with each other. So there's this thing called the Serialized Block. Do you know about it?
Oh, yeah. Yeah, so I should talk about the Serialized Block for completeness. So the Serialized Block has nothing to do with any of the blocks I mentioned thus far. What the Serialized Block does is it gives you an opportunity to save some information for later. Why would you want to do that? Well, suppose that your effect is a sampler. So you need to press a button, you record the sample, and then you click on another button and it plays the sample. Simple stuff. You need to remember this sample. If you close your project and then reopen the project, you want your sample there. You don't want to lose your sample, right? So we need to store some information in the project file, your RPP file in ReaFIR. You need to store some information in there. Serialize allows you to do that. And the way that Serialize runs is actually quite interesting. When you are about to save the project, I think it's when you save, it runs the Serialized block in write mode. It's going to write to the ReaFIR project. And there you can store your sample, for instance. And then when you are about to load the project, it runs your init block, it runs your slider block, and it runs the Serialized block in read mode. So the same code, you write the block, the Serialized block only once, and it works in both write and read mode. The same code is executed in both modalities. And the meaning of some things changes when you are in read mode versus write mode. So the same code is interpreted in two different ways, and it's going to load your sample back into some variables for you to use in the block, the sample block, your JSFX block, whatever you need. So that's the Serialized block. And I don't think you are going to need the Serialized block unless you want to store the score.
I as you were explaining it, I was thinking about that. I mean, like, again, my ambitions always get ahead of my skills. But yeah, I was thinking of having like a high score type of situation, possibly giving a player full stats. Like, oh, you started at easy and you were getting 3 out of 10 questions right, and now you're at hard mode getting 5 out of 10. I don't know, big ambitions for that stuff.
You can draw a graph of progress over time.
Like stuff like that would be fun. What Bo is asking in the chat, I think, yeah, that's how I understood it. So basically, your block size, my block size right now is 256. So it grabs a block of audio, and then the sample is a loop that runs basically 256 times. So it goes for sample in block, do, and then it does a thing, right?
Yes. And Bo is asking whether the block runs on every sample block. So in your case, 256 samples. I think that's the case, but I'm not 100% sure. don't know exactly how this works. I guess we can always try this out. It's not hard. We can have one of those counters, those debug variables, to count the number of times that the block will be executed compared to the number of times that the sample block has been executed. The two numbers, if they divide to a result of 256, we have our answer. But I don't know the answer to that. I think I read somewhere that these numbers don't correlate. Your sample size, your block size in your ReaFIR configurations, and the number of times that the block is going to run doesn't exactly correspond one to one. But I may be misremembering.
Well, could it be that it runs at block size, but not the sample rate? The sample rate times the number of channels?
Yeah, I don't know. We can always do a quick experiment to find out, but I don't know the answer to that. But yeah, I want to mention before I move on from the serialized block, there is something else about the serialized block that is kind of interesting and I want to share. I learned this from reading either the documentation or the source code. I think it was the documentation for that library, the user interface library you're using by Gereintlove. I don't know. So what you can do in the serialized block is store your plugin version number. And I do that in my AutoMixer, for instance, because if I ever want to update and I want this update to be breaking, it's going to break existing instances. So if you have an old project with my AutoMixer and you update the AutoMixer and then you reload that project, in my serialized block, since the get-go, since I released the AutoMixer the first time, in my serialized block, I stored a number, which is my version number. It's just a plain number. Think of it like the number 1.
Right.
Anytime I change something in the code, I update that number, number 2, number 3, number 4. And I never needed this. But if I ever need to break something in the AutoMixer, hasn't happened yet, but it may happen in the future, so I'm anticipating that by having stored that number. What I can do is, in my serialized block, I can see, oh, now there is going to be a break change. I'm going to do something that will break the effect. So I can look in the serialized block, oh, you have an old version of my plugin. Let me do whatever I need to do to change this. So maybe I can change some slider values. Maybe I will just give you a warning saying this doesn't work anymore, whatever the case may be. But I think it's very useful. If you have something more ambitious, like your effect is now, you may want to update it in non-backward compatible ways. So it's nice to store a version number there. And if you go to that library, either in the documentation or the source code, you're going to find a snippet. You can just copy and paste, and it's going to store the version number. You can also go to my AutoMixer and copy and paste from there. So yeah, serialized block, it's useful for that, but it's not useful for communicating between blocks. So if you have some, and I guess that's your issue, you have something in your sample block, your block, and you want to communicate that information to the GFX block or to the slider block or whatever the case may be. To do that communication, all the variables exist in every block. So if you update your easy guess variable in your block, like you do right now, that easy guess variable is available in the GFX block. You just have to keep in mind the execution model of JSFX. So when you're running the block to update easy guess, the GFX block may be running at the same time. So if there is a relationship between the easy guess variable and the easy answer variable, you need to be mindful of that. Because in the GFX block, you may be showing the easy guess variable that has been updated, but the easy answer has not been updated yet, because the two are running at the same time. So you may be in the block execution, you may be exactly at the point between easy guess and the easy answer being updated. Does that make sense?
Yeah, and I did run into this issue, and I guess so. One thing that I would add, and correct me if I'm wrong, obviously. So yeah, like I could communicate between all the blocks, but I could not. So you can send, like I can send from the block size something that would change a variable that is tied to a slider, and the slider. But the slider, so once the slider changes, I guess I just got what happens. So you can change a slider value from the block, but that doesn't mean that it would go and read the code again with that value updated in the slider block. So you have to,
Yeah,
okay.
what we learned last time is that when you programmatically change the value of a slider, so it's not the user interacting with the user interface. You, the programmer, wrote some code that will update the slider value. It does not trigger the slider block again.
Mm-hmm.
And that can be problematic. So one way of solving this is to have the whole slider block in a function. And then you call that function whenever you update a slider programmatically. So that's something you can do. And I remember running into a very weird edge case in which having a serialized block, even if you had just nothing interesting there, you can write add serialize and then a number 0, which is just dummy code, so that that block exists. I remember it changed the execution model of the slider block, I think. It changed the execution model in an interesting way. And that came up in the automixer, but I don't remember exactly what the change is. You have to watch my code review for that, but maybe having a serialized block will help you in that situation, even if you don't want to use a serialized block.
Yeah.
You can try it out.
And I wish I hadn't forgotten all this, because it was 2 weeks ago that I was playing with this. But yeah, I did add a serialized block, and it did break a bunch of other stuff. So I was like, all right, I don't get this yet. Let's step away from it. And I guess I already know the answer to this next question, but there is no way to, because I mean, okay, our slider block right now, right? It runs every time the user interacts with the parameters, but there is I'm assuming there's no way to tell the JSFX, or I guess there is. Can you tell the JSFX don't run anything on the sample block or the block until somebody touches something on the slider block? I guess you can just say set a variable that's your first line of code, and it needs to.
Yes, that's how I would go about this as well. There is, as far as I can tell, no native functionality for this. No way for you to tell ReaFIR don't run this block until I'm ready. But you can always have a variable that you update on the slider block, which determines just a number like 0 or 1. And then in your block, you can have a big if that is like, if my variable is 1, then run. Otherwise, don't run.
And yeah, so it's some of those things that I think right now like need to be optimized in this, because like so right now you can generate a new question, all of that stuff works, but between two filter changes, obviously there's still a click. And I'm wondering like if there's a way to do maybe like every curve that comes in with a slight 30 millisecond or whatever curve, so that it's not like a sudden jump, and also it just makes it less challenging, because if if the first question that's generated is a low shelf cut and you immediately go to a high shelf boost, it makes it that much more obvious, versus this one like zeroing out and this one coming up would be better. The other thing that I need to address is, well, there's like one line of code that kept me from going further forward, and I just don't I watched the last stream again, and I still didn't understand this line that we wrote, specifically this low shelf thing that we did. I don't remember why we did it or how we did it, and maybe you don't remember, but I can.
No, I do remember that line. Yes.
Cool.
Yeah, so what we are doing on that line is you have made your guess, and we are about to present the answer. So that line reads easy answer equals, so we are about to, easy answer is one of the sliders, I suppose. Yeah. And we are about to change the value of that slider to reveal the answer. And then we are checking, is the filter type equal to low shelf? So is the answer, filter type is our real answer. That is the actual variable that is used below in the code that actually does the filtering. So filter type is the actual answer. So we are checking, is the filter type equal to low shelf? In other words, do we have a low shelf going on here?
Right.
If so, then this other low shelf variable is just a number. It's one of those enumerations that we talked about.
Right.
It's just a number that is the number of the low shelf option in the drop-down menu that is our answer.
Right.
So what we are doing is, why do we have the filter underscore low shelf variable and the low underscore shelf variable? We have these two variables because in the two drop-downs for the question and the answer, or I don't remember, but in the two drop-downs, the low shelf appear in different positions. So maybe the low shelf is the first option in one of the drop-downs and the third option in the other drop-down for whatever reason. So that's why you have two of these variables. So all we are doing in this line is, if the filter type is equal to low shelf, so if the actual filter that we really are using is a low shelf, then show low shelf as the answer.
Cool.
Otherwise, show option number 2. So we need to know whatever is the option number 2 in the easy answer slider in the dropdown. That's what we are showing. I don't know what that is. It's probably high shelf.
Yeah.
And probably we have a number 2 instead of a variable there because we said, oh, we are going to complete this enumeration later. Let's just hard code the magic number in there for now.
Yeah. So I guess what we learned from this is that when you simplify the code to make it one line, it has so far confused me a couple of places, but now I got the logic. And if only this was, if this was in the next line, I would have gotten it, but I never paid close attention to this being a colon instead of a semicolon. So doi. Problem solved.
Yeah, and there is another confusion going on here that I want to clarify. We are using this, I'm going to give you this a name. You know the question mark and the column? That is called a ternary operator. We are using this operator in two different ways. In this line, we are using the operator to select between values. Low shelf is a value, the number 2 is a value. And we are selecting between the two based on the condition of whether filter type is low shelf. So we are selecting between two different values. And in other places, like above, you have easy guess equals 0 question mark, and then you have a block of code, and then you have a column, and you have another block of code. In that case, we are using ternary operator to select between two different blocks of code, not between two different values, but between two different blocks of code. So the same ternary operator, the same thing with the question mark and column, can be used in two different ways. It can be used to select between two different values. It can be used to select between two different blocks of code. And we are using both ways. And I never fully explained this difference in modality, this difference in use. If you really look under the hood, they are the same thing.
Right.
Under the hood, they are the same thing. In fact, what we have on the line, easy guess equals 0, question mark, blah, blah, blah. What JSFX is going to do is it's going to run your block, one of the two blocks, right? So it's going to select between the two blocks. It's going to run one of them. For instance, let's say that it runs the second block, the one that starts with easy answer equals blah, blah, blah. And then on the next line, it reads time of guess equals time. Right? And then whatever is the last thing that you have in your block, for instance, in this case, it's time of guess, that's what gets returned by the whole ternary operator. It just so happens that we don't use that for anything. We drop it on the floor. We don't have anything in the line that reads easy guess equals 0. We don't have any variable whatever equals easy guess equals 0. But if we had, that variable would have the same value as time of guess if we ran that block of code. If we had run the other block of code, it may have the value of dB gain, which is completely nonsensical. dB gain is one thing, time of guess is another thing. One is in dBs, another is in time. Completely unrelated, but you would have a variable that behaves that way. It's a variable that is crazy. That crazy variable is sometimes a dB value, sometimes it's a time. You have to use it very carefully, but it's something you could do. And in some cases, it may be helpful to do that kind of thing.
Interesting.
So there you go. That's the full story on the ternary operator.
Cool. So this brings me, every time you explain something, it clears up a few things and obviously creates a few questions. But I'm going to hold this next question. Or I don't know if I should hold this next question. Because now what I'm seeing is like, okay, we did the easy thing, right? Let's say we're ready to graduate to medium, right? I guess what I would need to do is have like a disengage value that when you choose like medium difficulty, it will go to easy mode and turn easy guess to not 0, maybe turn it to -1, so that this whole line of code doesn't run, because this line of code changes the filter type to low shelf and high shelf. And in the medium difficulty, we are doing like band soloing. So, well, it's not really a question. It's just something I realized, fuck, we gotta do.
Not really, because I'm sure that whatever you are doing on the medium will be to set up the filter type, right?
Yeah.
So you're going to overwrite whatever decision that was made before.
Okay.
So I think that's okay. I think it's unnecessary and kind of confusing that you run that block of code, but I don't think it has a big consequence because you are going to later overwrite that variable.
Oh, okay, gotcha.
I still think it's a bad practice for you to do it that way, and I advise you to separate things so that you don't run blocks of code that you shouldn't.
Yeah, because I mean, one thing that would happen if this code is ran but just not regarded is that maybe at one point in the code, the user will get a point because the answer and guess happen to be the same thing, right?
Correct.
Yeah.
Yes.
So we need to kind of be like, okay, we're in easy mode. Don't run anything from medium, hard, clear mountain difficulties, and then we switch that. So I guess, yeah, like the things that do you want to see how it works?
Yes.
Okay, let's do that. So just a few things about the sound part that has changed. Now the frequency will be randomized, and it will be it'll basically be between 100 and 1K on the low shelf side, and it would either cut -6 or boost +6. And when it comes to the high shelf, it will be between 6K and 10K, and it would cut 6 or it would add 3, because adding 6 would be too much. I also put one of your limiters on there. And then it gives you a point. So it counts the total question. It gives you a point. We'll figure out how to give that to the user later.
Pause.
Oh, go on.
Pause. I want to ask about that line you wrote, ran 900 pipe 0. What's that about?
So rand obviously generates, so in this case, random generates a number between 0 and 900 with decimals. So I just took away the decimals. Not that it would matter. Frequencies could be in these decimal values, but it was just looking kind of nicer to me. So then this whole value is generated, and the cutoff will be at like 996, something like that.
And why do you? Essentially, what you're doing, I guess, is truncating the number. You have a number with a bunch of decimals. You're truncating it to its integer part. Why does pipe 0 do that?
Yeah, that's a great question. You tell me.
Yeah, so we learned what pipe is. What is the pipe character? What does it do?
It compares two numbers. Oh,
yes.
So 0 doesn't have... No, tell me.
Yeah, so pipe is one of those bitwise operators we used when talking about masks. And specifically what the pipe bitwise operator does is an OR. And it's an inclusive OR in the sense that if you have either one of the operands as 1, then the output is 1. They're both 1, the output is 1. If it's 1, 0, the output is 1. If it's 0, 1, the output is 1. The output is only 0 if you have 0, pipe 0. Okay? Remember that guy?
Yeah.
Okay. So it is looking at these numbers as bits. It is a bitwise operator. And OR 0 doesn't do anything to a number because 0 or 0 is 0 and 1 or 0 is 1. So x or 0 is x. It doesn't change x. Or 0 doesn't change anything, right? Well, why do we have that then? You probably lifted this from some other piece of code using in JSFX, right? Okay, so you find this a lot. Why would people say pipe 0 when it doesn't change x? It doesn't change the number. Well, it doesn't change the number, but it changes the interpretation of the number in JSFX. So if you have a number that has a fractional part to it, and you say pipe 0, you don't want to change the number. You don't want 200 to become 500. That's why you don't say pipe 1. You say pipe 0. But it's going to change the interpretation. Usually a number is interpreted as a fractional number with a decimal point and a bunch of things after it. But when you put it through one of these bitwise operators, JSFX and other languages like C, I think C also does that, and I think that's why you see that in JSFX. It's going to change the interpretation. It's going to see, oh, look at that fractional number over there. It's being used here with a bitwise operator. I cannot really apply a bitwise operator to a fractional number. So here's what I'm going to do. I'm going to convert this fractional number into an integer, which I then can pass to the bitwise operator. So you can use the bitwise operator. Let's do a few peeks to understand what's going on. So write down, for instance, 2 pipe 1 and peek at that. But before you peek, think about what you expect to come out.
1.
Why?
Because it is comparing number 1 to number... So we said if it's... Oh no, we said if it's x or 1, it'll be x, so it's 2.
Well, actually we said that it's pipe 0.
Oh, sorry, yeah. So 1, does it times the number by 2?
Not really. Write the number 2 in binary. On the line below, write the number 2 in binary.
So number 2 in binary is 1, 0.
Exactly. And write the number, go to the next line and write the number 1 in binary. Yes, and pad it with a 0 to the left so that the two numbers align.
Cool.
And now we will do the bitwise operation. Go to the next line after the 2 lines you wrote. And let's do the bitwise bit by bit. So 1 or 0, what is the output of that?
1 or 0 is 0.
1 or 0 is 1.
1 or 0 is 1? Oh.
Yeah, only 0 or 0 is 0.
Oh, okay, yeah. Okay.
So go to the line above and just leave the number 1 there. We are doing this like you would learn how to do addition in grade school.
Yeah.
So we are doing the operation bit by bit, going from left to right. 1 or 0 is 1. And then 0 or 1 is... What is 0 or 1?
1.
Yes, exactly. And what is the number 1, 1 in binary?
It is 3.
There you go. Peek at 2, pipe 1, and see if 3 comes out.
Hey, okay.
You got this. So now try 2.5 pipe 1.
Okay, 2.5 pipe 1. So it's...
What do you expect to happen?
So I guess it's doing the same thing, but this time it's just disregarding the decimals.
Yes.
So it will be 3.
So when ReaFIR looks at this, it says, oh, 2.5 pipe. Well, it's asking me to do a bitwise operation, but this number is not an integer.
It's a float.
So let me go ahead and convert it to an integer. It's a floating point. Yes, that's what it is. It's a floating point. So let me convert this floating point into an integer so that I can do the bitwise operator. And how does it convert from floating point to integer? By truncating the decimals. So it's going to output 3 as well. Select and peek, and let's verify.
Yep, cool.
Yeah, it's still 3. And it's important to note that it's not rounding, it's truncating. So if you have 2.1, truncated to 2. If you have 2.9, truncated to 2. If you have 2.99999, truncated to 2. Doesn't matter, just ignores whatever is after the point.
Got you. So, okay, so for example, I guess if we're doing something like... I'm just throwing something out there. Something like this. Whoops. Butterfingers. So it's basically taking these numbers, turning them into binary, putting them underneath each other, comparing those, and then whatever binary is resulting from that, that's our guy.
Exactly.
Cool.
That's what's happening.
Cool. Finally got it.
Yeah, so now we understand why pipe 0. The pipe 0, you can work this out with 2 pipe 0, for instance. Let's actually do this. Go to a new line and say 2 pipe 0, and then let's work this out in steps. So we know what the number 2 looks like in binary. We know what 0 looks like in binary, and we know what the OR is going to look like. What is 1 or 0?
It's 1.
What is 0 or 0?
It's also 0.
Yeah, so you see how it did not change the first operand. What was 1, 0 is still 1, 0. It doesn't change the number, but it changes its interpretation. So if we had 2.5 pipe 0, it wouldn't change the number, but it would truncate the decimal, so it could apply the bitwise operator. So the pipe 0 thing is a hack. That's what it is. It's a hack. It is aware. It's a hack that is aware of the fact that when you try to apply a bitwise operator to a number that is not an integer, it will be converted to an integer in this specific way that is not rounding, but truncating. So pipe 0 is a huge hack. It happens to be very concise, and it is somewhat common, but it is a hack, and there is something more readable. So again, I am bringing this to the readability side. It depends on who you're talking to. If you are talking to someone who writes a lot of C, pipe 0 is going to be commonplace, and they will say, oh yeah, this is super readable. But we had to have this conversation for you to understand what that how that worked. Instead of doing pipe 0, another thing you can do if you want is say floor. It's a function that comes with ReaFIR. It's called floor. And it receives as argument a number, and it is going to return the number without the decimal part. So go ahead and peek at that.
What did I do? Wow, I'm having major butterfingers today. Sorry. Well, I shouldn't have written the biggest number in the world, but
it truncated the number.
There we go. Cool. And it kept the decimal points, I guess, which is nice in its own way if you want to do something.
Well, that is also the case of the pipe 0. Select the 2 pipe 0, 2 or 0, and peek at that.
Oh.
See, the decimal point is still there. When showing the number, all numbers are floating points when showing them to you. In at least on the peak, if you look at the right pane, integers are not shown with a dot, a decimal. But
cool.
But it's important to note that even integers really are floating points in some circumstances. Let's not get into that. So yeah, floor. I find that preferable. It is more verbose. You have to write some more. but I prefer that version. You do whatever you want.
So just to make sure I got it, so I would do floor of rand 900, for example, and then I can get rid of this bit, right?
Exactly.
Cool.
Yes, exactly.
And what did I do? Oh,
I find it very important. I think you need to remove all that boilerplate. All that test code. You need to remove that for that to really compile. But I wanted to take this tangent because I think it's important that we learn the stuff that we copy and paste. And it's completely okay to copy and paste. I am a professional programmer. I do that for a living, and I copy and paste the entire day. But I find it very important that I learn and understand what I am copying and why it works.
Oh, yeah, absolutely. And also...
And in some cases, I think, you have to trust yourself. I mean, like, you find this pipe zero trick all over the place, but you have to know in your heart that, no, I prefer to write floor. At least I do. You may not, but I do. I know in my heart that I prefer to write floor because I find it more readable. I find that people at least will be able to put their cursor on top of the floor function and see the documentation on top. So, or if they need to learn more about it, they will hit F1 in their keyboard and they will be taken to the ReaFIR documentation for this. Did you know about this?
Yeah.
Something you can do.
Yeah.
Hit F1 and you will be taken to the ReaFIR website with the documentation for floor and they'll learn about it. While the pipe zero is magic.
Right, yeah.
So that's my way of writing code. And it's not the right way. It's just my way.
No, I totally agree with you. Yeah, and its readability is super important, especially because we're like, oh, come learn with us kind of situation. And yeah, I mean, speaking of like copying code you don't understand, now that I'm working with the UI, I just kind of started with the assumption that I'm never going to get it. So I'm just kind of like trying to copy and like MacGyver things together. But when you don't understand it, you change a value that you think has nothing to do with anything in the world, and it breaks your whole code. Like, where is my... Yeah, here, I don't remember what I changed. Things were working good. I had a difficulty here. You could select like medium mode, easy mode. It was all good. I changed one thing. The whole thing is now like upside down and all over the place. So when you don't understand the code that you're copying and pasting, like you can modify, oh, if I change this string from vibrato to question, it'll become question, duh. But like once you really get into it, yeah, if you don't understand it, you're just going to break your code and you're just, you're coding as if you're diffusing a bomb. Like, should I cut the red wire? Should I cut the blue wire? The whole thing may blow up.
And I find that fascinating. I love learning like that. There are all these different ways to learn. You can learn by doing that, copying and pasting and changing and experimenting. You can learn by reading the docs. I do some of both. I learn in all different ways. I read the entire docs for the library that you're using to do the graphical user interface, and I never used that library. I just read its documentation and I read some of its source code because I thought it was fascinating. It was a fascinating read. I just didn't want to use it. And then in some other instances, I don't read the docs. You go to my stream. I am now coding in Electron. It's this JavaScript thing to do desktop applications. I know very little about it, and I never read the documentation. I'm just going, searching parts, copying and pasting, making it work. So you do some of both, some of all the ways you can learn, and they are all valuable, and there is no wrong way. If someone says that there is a wrong way, they are wrong.
Right.
And I may be wrong right now. I don't know.
Yeah, I mean, there's probably some wrong ways. If you say, you know, I remember, I don't know. It's when you say stuff like, oh, there are no wrong ways to do something, or when you go, there are no stupid questions. The universe goes, challenge accepted, and then somebody goes, hey, is ReaFIR better or Pro Tools? And then it's a whole but yeah, I know what you're saying. Bo's question goes over my head, but have a look at that.
Yeah, so if there's time, could you explain how converting to absolute values with y equals abs x, then running code, and then using y times sine of x to convert back? How does that work, and where can I read more about it? I don't know where you can read more about this. But I can explain what's going on. So in some cases, you are interested in a number both because of its magnitude as well as in its sign. When I say magnitude, I mean, is it the number 1 or the number 5? And when I say the sign, I mean, is it 1 or -1? So in some cases, you're interested in both the magnitude as well as in the sign. For instance, when we are dealing with samples, if I give you a sample that reads 0.5 and a sample that reads -0.5, that is significant. In one case, your speaker is going halfway out, and in the other case, your speaker's cone is going halfway in its travel distance. So that's significant. But in some cases, you don't care about the sign of the number. You only care about its magnitude. For instance, if you're measuring the loudness, or actually the pressure, the power that is happening when the speaker cone moves. So if the speaker cone is going to half or to -half, it doesn't matter. It is still going to produce the same power. It's still going to be heard on the same loudness. It's still going to be perceived as a sound with the same loudness. It's going to, in other words, push or pull the same amount of air, and the same amount of the column of air that's going to be pushed is the same. So you hear that as the same loudness, roughly speaking. So in some cases, you are interested in the sign of the number. In some cases, you are only interested in its magnitude. In some cases, you're interested in both. So there is this trick where you take, well, first of all, suppose that you are interested only in the magnitude of the number. So say that X is a sample, and you are doing some computation of that is related to the loudness, roughly speaking. So you are only interested in the magnitude. Then you can use this abs function. It stands for absolute. And it does the thing, in mathematics, it's represented with 2 lines on the sides of the number. So if you have a number like 5, the output is 5. And if you have -5, the output is 5. It just ignores the sign, gives you the absolute number, or the magnitude of the number, as I am calling it now. So now what Arya has on the screen, X is -2,376, and Y will be 2,376, as you can see in the blue bar on the bottom.
People may not be seeing the blue bar, which is a big fail on my end. So sorry, Bo, if you don't see the blue bar, now you do.
Just trust me. Yeah, there you go. So that's the magnitude of the number. So in some cases, you are interested in the magnitude of the number, and then you go ahead and you run this code and you calculate whatever you want with this absolute number. So maybe you calculated your sound pressure based on Y, the variable Y. And then, for whatever reason, you want the sign back. You want the number to be -2,376. Why do you want that? I have no idea. Maybe you want to use that to send that to the speaker. You want that to be a sample. So you want to get back that information of whether the speaker's cone is moving out or in. You want the sign back. So what you can do is use the sign function. The sign function is going to just return 1 or -1. If you give it a positive number, it's going to return 1. If you give it a negative number, it's going to return -1. So that is a number that you can multiply by your Y and get back your original number. So when you do this thing, you are back to X. Why would you want to do that? Arya, you have to select the whole block. You have to put semicolons and select the whole block, because otherwise X may not be available to you.
Oh, I see.
That's why you got the weird result there. I think that by default X is 0, because every variable by default is 0, so you got a sign of 0. Sign of 0 is 0, by the way. So sign of any positive number is 1, sign of any negative number is -1, sign of 0 is 0. You have to select the whole block, I think.
Oh, like all the code from up here?
Yes. So why would you want to do this instead of just... See, the number is now minus 2,376. So why would you want to do this if you already have X? Why go through all this handstanding to get back to where you started? I have no idea, but in some cases it may be useful. I don't know. So let's read what Bo said. I've learned to use it in formulas that, for example, squares the samples, i.e. all samples go positive. So you use sign to convert it back. It's just that sometimes it doesn't work. Yeah, I don't know why it wouldn't work, but something to know, it's actually kind of interesting. Bo is saying that you square to, and so all numbers are positive. And I talk about this in a series of videos in which I talk about the computation of RMS, this measurement of the power level of a signal. And in RMS, the S in RMS stands for square. And you take all the samples and you square them. So -5 and 5 will both become positive numbers. In that case, 0.25. Both become 0.25. They are all positive, which is a way of turning all your numbers positive. Instead of using abs, you square the number. And it just so happens that your number is no longer 2,376. It's 2,376 squared. But for physics reasons and whatnot, in some cases it is advantageous to have the square of the number. In particular, it relates more to the relationship between the voltage, which is the sample, the number between -1 and 1. That is a voltage that goes to your speakers. And then the actual cone of the speaker, it's not a cable, it's not a voltage, it is an area. So if you want to talk about the sound pressure, it makes sense to square that voltage instead of just taking the absolute value. That was a huge tangent, but there you go. That's why some people use abs and then sign to convert it back. I don't know why that would be useful. You may want to do something with the squares, but if you do it with the squares, remember to use the sign of the original value, not the sign of the squared thing, because as you mentioned, when you square, the negatives go away.
How do you do?
End of tangent.
How do you do real quick the old this thing? Say this is where I learned the name in Farsi, like square root of x. Because I know you can do 2 to the power of x.
If you want to take the square root, you can use a function. It comes with ReaFIR. It's called Sqrt.
Oh, we used it in the EQ. That's right. Okay, so square root of x.
Yes.
Oh, okay, cool.
Yes.
That's fine now.
If you want some other root, which is not the square root, if you want
cubic root,
yeah, that kind of thing, I don't think you can do that with Sqrt. Can you go to the docs for Sqrt real quick? Just put your cursor on top of it. Yeah, it just takes a single parameter. So you cannot use Sqrt to take root power, not a power, cubic root. You cannot do that. But what you can do is take x and power it to 1/3, for instance. And then you get your cubic root, if you remember your arithmetic.
Yeah.
From high school.
More or less.
But if you don't, it's okay. Don't worry about it.
Okay. Cool. So hopefully that answered your question. The old squirt function or pow. Oh, okay. Cool. That's nice. I get that too.
Oh, pow. That's nice. Pow is just a function that does the same thing as the caret. You can say 2 caret 0.5, for instance.
Yep.
Or you can say pow 2, 0.5. It's a matter of taste. I don't think it makes absolutely any difference.
Cool. They are.
The line that you had before and the line that you're writing now are both the same thing.
Cool. Well, I learned some new stuff, so that's cool. So, all right, you want to hear this thing? You want to do a quiz?
Yeah.
Cool. I'm going to close the thing so that we don't peek at the answers here. Do you want to test it with white noise or with audio? I find with audio it's a lot harder.
Give me white noise then.
Okay.
I am bad.
Okay. So this is your white noise. Tell me when it's good level.
Bring it down a little.
Okay, and I'm gonna choose easy. Okay, and I can A/B it for you. All done. Since
Okay.
this may not have done anything because it's a lot more obvious. So let me just make sure that we're in the right place. Okay. Here we go. No, it seems not to be working.
Oh, yeah, I was gonna say I don't hear any difference and I have a guess.
Hold on, what could have gone wrong? I didn't change anything. I knew I literally was like, you know, as soon as we start streaming, this thing that I tested so much is gonna stop working. Okay, let's try one more time. Okay, now it's working. All right.
I think it's a high pass.
Yeah. So low shelf, high shelf, this is low shelf. And is it a cut or a boost?
It's boosting the highs.
Is it?
I hear more of the highs, I think.
I think it's a low shelf cut. I don't think it's doing anything to the highs, so let's check. Yeah.
Is that your easy thing? I find that kind of hard.
It's... Well, okay, so I tried... Quick spiel. I tried to... Yeah, it's not super... Well, it's not super hard, but it's not super easy either. But I tried to dial the values in a way that would make it easier. So you're never having to like listen to like a 60, you know, like a low shelf at 60 hertz going down 1 dB, because that would be really hard to hear. The values are actually like a lot of them fall into the mid range, so it makes it slightly easier. And at the beginning, like it wasn't so easy for me. While I was doing testing, I did maybe like 300 of these, and now I can bang them out. So, yeah.
Do you think that you got better with this?
Oh yeah, like the easy I can get pretty much 100%.
And do you think that it's an important skill?
I think it's good. Yeah, I think it's good to, well, especially like with the medium mode and hard mode and all of that stuff. Like it is a little bit of, it's like going to the gym for your ears. So it won't necessarily make you like a better producer, but it will definitely make you hear EQs better. And this is something they made us do in school that really helped me. And that was like a human. So our professor would turn off the screen projector. He would do an EQ move, and then we had to guess what it is. And it just made me kind of rely on my ears, and it made me listen differently. And, you know, they say, oh, don't mix with your eyes, that whole spiel. I think when you like have some parameters that you're changing, you start to listen for that bit of the sound. So if you're listening to a compressor, if you're adjusting a compressor, you're listening for compression. It's much harder for somebody to do something and for you to detect that as compression. So it kind of makes you start listening to things a little differently, rather than seeing like, oh, well, I'm cutting the low end, let me pay attention to the low end. You just pay attention to the whole sound. And you go, oh, less low end. Oh, more, or the thing that happened to you where it's like, okay, did you actually add high end, or did you just cut the low end, thereby providing the illusion that the high end has been increased, right? So I think it's helpful. And then the easy mode is pretty easy. I was even thinking of promoting medium mode to be easy mode. But Yeah, it's the.
I mean, can we have a new difficulty that is the Leandro difficulty, and it's even easier than easy, and you give me something very, very basic, the most basic thing you can think of.
Sure, it could be
Maybe
low pass or high
maybe
pass.
it's always a cut. Maybe it's always a cut, or maybe it's just, is it a high pass or a low pass?
Yeah. But I think, okay, let's do like 2 more questions with you, and I think you will like nail the next one.
Yeah.
So once you do the guess and it reveals the answer to you, after 5 seconds, it'll change it back, and then it will say click to generate a new question. So you say go, and now it generates a new one. So I'll A/B it for you again. If you're having a difficult time, I'll turn it up a little.
Yeah, do that. When you enable the effect, I hear less of the low end. So I'm going to say it's a low shelf that is cutting.
Yep, you're right. Boom, point. Let's do one more even.
Okay, I find that easier. I think I hear more of the high end. So maybe it's because I am using this, but I think I hear more of the high end. So in this case, the high end is going away. Now it's only a question of, is it a high shelf that is cutting or a low shelf that is boosting? I don't hear a lot of difference in the low end. So I think it's just the high end going away. So I'm going to say high shelf cut.
Yep, nailed it. Nice.
Go me.
Yeah.
Yeah, I asked you this, but I too find this very useful. I think it's a nice skill to have, and I think I want to get better at it, so I want to play this game. And it's not only for mixing, it's also just for... And I find that that's one of the motivations for me to want to learn music. I'm not a professional musician. I don't think I will ever be. And it is so that I can appreciate music better. So I will be able to say, oh, I like the thing that I like because the person did a really good job at EQing all the instruments so that I can hear all of them clearly. Or maybe the person did a good job of muddying the whole mix so to tell the story better or whatever. So I can have that kind of appreciation, which I think is a nice motivation to learn these things, even if you will never become a professional yourself.
Yeah, absolutely. And it can help with sound design and stuff as well. Because, like, one other exercise that the same professor made us do, he was like, grab some white noise, solo one of the 5 bands, and then you have to write a few words of things that this sounds like. So you start to kind of like, you know, and they say like, oh, the Inuit people have like 30 words for snow because snow is so much more like relevant to their experience than somebody living in the Middle East. They just have a word for snow. It snows every once in a while. So it's also a way, like, we don't have too much vocabulary to speak about. We can speak about bright, we can speak about boomy, muddy, woofy, all these words. But it's cool to, like, just have more words, like, really have a word for 3 to 7K, SE, and then have a word for 16 to 20K, airy, right? It just helps us kind of, like, hear the spectrum and be able to like put words and even images to it, you know?
Yeah, I find that actually an interesting probably area of research because I don't know much about this, but I don't know much about many things. But the thing is, we have a fully developed theory to talk about pitch. We have notation for pitch, we have conversations about harmony, but there is very little in the way of notation or language for these other qualities of sound. For timbre, so how do you even talk about it? You can see the harmonics maybe, but that's not a good way to have this conversation. And I find that is so important, especially in modern pop music. It is very little about harmony or even melody. It's a lot more about timbre. So we should have this kind of language, and I don't know it.
Yeah, absolutely. When it comes to timbre, it's quite limited, and it took until like the 20th century, I feel like, for musicians to kind of go that route with people like Xenakis, and he did try to kind of like create words to ascribe to different timbres. So in what way? And he uses some things that we like kind of can understand. So shrill, it would mean lots of overtones. Certain words like that, but then like, you know, you hit different walls. Like how, in what way, what word can we use to describe the difference between the timbre of a trumpet versus the timbre of a clarinet, let's say, right? And it gets a lot more complex at that point. And this is one of the things, like again, a question that's asked every day on various forums. It's like, well, why do I have to learn music theory? I have a good ear, I can make a song. And it's like, yeah, obviously you totally can, and you should. Don't learn music theory. But if you as a guitar player need to explain your music, you need to communicate your music to a sax player who's joining you for a quick jam, you're not going to be able to, well, I'm playing fret 2, and then, or they can kind of hear it by ear and play it by ear, but really, like, music theory is also a way for people to communicate with each other. They go, this is our key, and we're going 1, 4, 5, and we're modulating to blah, 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 and this is our time signature. So it's...
Yeah. As you can imagine by the fact that I devoted 6 years of my life to a PhD in programming languages, I am very interested in how people communicate ideas. I am very interested in language. So I develop languages. That's what I do. And when I am writing code, I try to develop a language that makes sense to communicate the ideas that I need to communicate in my code. For instance, the thing that we were talking about, how you can use pipe 0 or you can use floor. It's a very simple example, but it goes to show that I'm thinking about communication. I'm thinking about not only I want to make this short or kind of cute or insiders. I know this cool trick from C. No, I want to communicate clearly, and that's my goal.
Yeah, absolutely.
So having language and creating language, I always find fascinating.
Yeah, and like in the ReaFIR community too, so you have like people like X-Frame, and I open his codes, and there's tons of comments even. It's like, I don't know why this works, but it does. Like he explains it, and then there are other people like doing the same thing, and their action works and everything, but I can't necessarily like just take a glance at it and be like, oh, that's how that works. So I think you have definitely convinced me to aspire to go for like readability rather than kind of conciseness of code. So I don't know how much time you have, but what I want to... So there's a couple of more like pressing things. One pressing thing is like the clicks and pops. That's kind of something that's got to go away. It also clips. It never clips while the quiz is being generated. Just when you're transitioning between two questions, it clips for a few samples. So right now I just put the old trusty limiter, or I thought I put the limiter there. Oh, I put the limiter only on one of the tracks. There to just kind of deal with it. But that would be a good feature to add. And it would be good if it's also stereo compatible.
Do you want a limiter? Do you want... Oh, yeah. So, yeah, very good points. Do you want a limiter to be embedded in your random EQ experimental? Do you want it to be embedded in the game, or do you want to just not produce clipping?
That's a good question. So yeah, like, I mean, we can talk about whether to have a limiter embedded in the code or not. What I'm interested to learn about is more like when I unbypass and bypass this I get a pop or a click, and I don't get that with other JSFX. So what's the trickery there? And
Yes.
also, if possible, for when you generate a new question, if the curve can like ramp up from gain being 0 to being +6 or -6, that would be nice. And another thing that I need once we get to medium, so medium already starts using 2 filters. So it would use a high pass filter, it would use a low pass filter to narrow in on a certain band. So when we get there, what modifications? I was thinking I can like copy all these values, call them filter type 2, but then how would I add those here so that they will both apply to the signal, if that makes sense?
Okay, so let me see if I get this. I am taking notes. You want to talk about clicks? You want the transition between effects to be smoother, ramps. You want stereo, preferably multi-channel. Why not have a 5.1 thing going on?
Right, absolutely.
And you want to apply multiple filters. Okay, so let's talk about all of this. I was taking notes because otherwise I would forget. I'm gonna make sure I hit all the points. So, clicks and ramps are actually the same solution. The clicks happen because you are transitioning from one kind of effect to another so quickly that your samples go like boom, boom, boom,
right,
and then you hear a click. What you want to do is transition between the types of effects more smoothly. Remember how you create, when you create a JS effect, it comes with some boilerplate code, and I said that it was the simplest effect. It was just a volume knob, but it has some trickery in there so it wouldn't click if you automated the changes. Yeah, so we can apply a similar trick. The trick is to ramp. The trick is you're going to transition smoothly. And that smoothness may be noticeable if you go like for 40,000 samples, you hear the transition. Or it can be just 10 samples and you won't hear the transition, but it will not click. So how much you want, I guess it's an attack, right? So how much you want the attack to be, it's up to you. You may want to make it noticeable. You may want to not make it noticeable, so it becomes slightly harder for you to compare the previous question with the next one, which may give away part of the answer.
Cool.
So, but how does that work? Well, you're going to have 2 sets of variables. For every parameter you want to change, you're going to have 2 variables. So you currently have the cutoff frequency, it's a variable. And your dB gain is another variable, right? So for all of these variables, you're going to have 2 of them.
Right.
You're going to have the real dB gain, for instance. The real dB gain is the dB gain that is actually going to be used in your computation, that is going to be used in the EQ formula. And you're going to have a second dB gain. Let's call this the dB gain target.
Okay.
Let's call it that. The dB gain target is the dB gain that you have access to via sliders, or in the case of the game, that you're going to modify when you come up with a new question. Okay, so you are not going to modify the dB gain directly. You're going to modify the dB gain target. And then on every sample, every block, doesn't really matter that much, you are going to change the dB gain so that it's closer to the target. But you're not going to do it instantaneously. You're not going to say dB gain is equal to dB gain target, because that would be an instantaneous change. What you're going to do is you take the dB gain, the dB gain target, and how about just add it and divide it by 2? Take an average, whatever. Do something that will take you closer to the target, but not quite there. This way, you are ramping into the target slowly. How much you want to go there? So if you add and divide by 2, you are going to get there more. You're going to get there faster. If you divide by 5, you're going to get there more slowly, because you're taking smaller steps towards the target. If you divide it by half, you are going even faster. You are going very fast because you're not taking much of the difference in consideration. So that's the solution that these effects you have on the screen right now, that's the solution they have. They just want to talk about gain. They are interested in gain. It's a slider. It's a simple slider. You can see above, it's a single slider. It's the gain. But there are two variables, the last gain and the next gain. And the slider itself is gain dB. And the gain dB would map to our target variable. That's the thing that the user has access to, the slider that the user actually moves around. It's our target variable. I'm calling it target because it's the name that some other effects use.
Cool.
So yeah, you have your target. That's the slider. And then you have your last gain variable. Your last gain variable is the one that is actually used in the effect. You can see in the lines that read SPL0 times equals last gain. That's the variable that is actually used. Right? And what they are doing is they are computing a step to take. So they have the target, our dB, gain dB variable, and you have your last gain, which is the actual variable that you're using in your computation. And you want the last gain to follow gain dB. So if you change gain dB, less gain will follow, but it will lag behind. Purposefully, it will lag behind. So if you have your slider right here, your dB gain and your last gain are together, and you move your dB gain, your last gain will follow, but it will be behind. And that's important because if you instantaneously go from dB gain over here to dB gain over there, which is something you can do, you can just click on the slider anywhere and it will instantaneously goes there. But your last gain will follow smoothly.
Right.
So you can switch to a different place and it will always be tracking and following the target. And now the question is by how much and how fast? Well, that's your d underscore gain variable. That's your d. The d probably stands for differential.
Right.
It's the difference. It's how much of a step you want to take towards the goal.
Right.
And they have less gain plus equals d gain as the last line in the effect. So at every sample, they are taking the last gain and they're moving it closer to the target. They are doing that by just adding. So if you have your last gain is right here, it's adding like 0.1, 0.1, 0.1, 0.1. It's just adding to get closer to the target. But how do you compute the differential? How do you compute the d gain? How do you know how much of a step to take and in which direction? Is the target behind me? Do I need to go negative, or is the target after me? Do I need to go positive, and by how much? To compute this, they have something on the block that defines the d gain variable. And what they're doing is next gain. So next gain is in amplitude. So they have to do an extra step here that I don't want to talk about. I have a video about this in my channel in which I explain the relationship between dBs and gains. Right. The essence is you want your slider to be in dB because us humans like that, but the machine talks about samples, numbers between -1 and 1, and you need to take this -60 something you have on the screen and convert that into amplitude. Right. So that's what the formula is doing there, and I have a video explaining the formula. But so the next gain, you can think of next gain as your gain dB, okay? So that's your slider.
Right.
In fact, you can see on the slider section, the next gain is computed based on gain dB. So that's your slider. So it's taking your slider, subtracting the last gain. The last gain is where you are right now. So that's the thing that will be used, the thing that is tracking, the thing that will be used in the computation. So it's taking the difference. So next gain is where I want to be. That's my target. minus where I am. That's the difference between where I am and where I want to be, right?
Yeah.
So that's my difference. And I don't want to go there instantaneously. If I just said next game minus, so think about this. And in fact, write this down. If you say, go to a line anywhere and start typing this out.
Sure.
But leave the code that we were looking at on the screen so we can refer to it.
Oops. Let me just make this a little zoops like this. All right. Cool.
Yeah. Go anywhere in the code, anywhere where you can type, and just type last gain equals.
Oops. Last gain equals.
And then, well, we know that the plus equals stands for last gain plus d gain, right? So say last gain plus d gain after the equal sign.
Oh, okay. After the
no,
okay.
after. Don't just use the plus equals. I want to make this very explicit. So last underscore gain plus d gain. But look at that. We are saying that d gain is next gain minus last gain.
Right.
Right? So replace d gain with next gain minus last gain.
Oh, okay.
You see where I'm going?
Yeah. No.
You're going to say last gain minus last gain. So they cancel out. So you will be instantaneously going to the new location.
Right.
That's not what we want to do. So you take the difference between next gain and last gain and divide by a number. So you are not going there instantaneously. You are going half the way there. You are going a third of the way there.
Right.
Or in this case, you are going samples block, which is a variable that comes with ReaFIR. It is the size of your block. So there you go. We don't need to do that experiment. Just peek at the samples block variable and we will know the size of the sample block.
Which is 256.
Yeah, I don't know. Select and peek. It is 256. There you go. You are all right, and I was hesitating for no good reason. So there you go. How much do you want to go there? Well, you want to go 256th of the way there.
Right.
And this code is actually taking advantage of that thing I said where you have your block, and it runs first. And then there is this tight loop that runs on all the samples. But your gain cannot change so fast. You cannot change the slider so fast. So it's only computing the d gain once for the whole block. It's a very minute optimization. You could just have copy and pasted that whole formula into the sample block. You would never hear the performance difference. But there you go. They optimized for that.
Cool.
So that's what's going on. What you're doing is you have to summarize 2 variables. For every variable that you care about, now you have 2 of them.
Right.
One of the variables is the target. That's your slider. That's your new question you have computed. That's your target. That's where you want to be. And then you have the actual variable, the one that you are going to use in the computation. The actual variable tracks the slider, but it lags behind.
Right.
It tracks with a delay, and it's a smooth one. So if your target jumps around, your follower will go there smoothly. And you do this by seeing the difference. Where is my target? Where am I? Subtracted 2. That's my difference.
Right.
Divide by a number. That number will determine how fast I'm going. And then add that differential to my original value.
Cool. So essentially what I would have to do is... So dB gain is one thing we want to control in this way, but I also then want to... So, okay, wait, let me ask my first question that was generated. So, you know that old like thing people say, ooh, like if you go half the way from your friend's, from your house to your friend's house, you will never get there because you're only going half the way. So this is similar to that in that we're never actually arriving at the final value because we're only walking up to it in increments that will never add up to the full difference,
Yeah, so
right?
do you want to know the full story there?
Sure.
Yeah, okay. So the full story there is that the thing you are talking about would be true if our numbers were true numbers. These numbers that we work with, the floating point numbers, the so-called floating point numbers, they are fake numbers. Going to explain why. So if you had your idealized numbers, you would go to your friend's house halfway, and then you would go halfway of the remaining distance, and you would go halfway of the remaining distance, and halfway of the remaining distance, and you will never get there.
Right.
This is a paradox. I forget the name.
Yeah, me too.
There is a cool name for this. It's a paradox. But because, in fact, you do get places, right?
Right.
How do you get places? Well, you get places because the universe is not continuous to some understanding of the universe. It's made of atoms. It is atomic. There are, like, you can think of the universe as a bunch of small samples.
Right.
It's not really continuous. This is a fake analogy for me to explain what what I want to explain.
I guess
but
Planck number is the sample rate.
Yeah. And you get to your friend's house because you go one atom at a time.
Right.
That's how you get there. Okay. We do the same thing with numbers here in the computer because we don't have infinite memory or a processor with an infinite pipeline. Our machine has a fixed size. It's this size. It's not a whole universe.
Right.
There are only so much numbers I can store in here. Even if I am super smart about the way I'm storing numbers, if I am using an abacus, I can only store 5 numbers. If I am using one of these computers, I can store trillions, maybe probably more than that, of numbers. But there is a limit. I can only store so many numbers here. Even if I use the spins of an atom to store a number, I can only store so many numbers here. So numbers in the computer are not real numbers. They are not true numbers. They are fake numbers. We use approximations to store these numbers. One of these approximations is called a floating point number, and it's a fake number. If you say 0.1 plus 0.2 equals 0.3, select and peak. Go ahead and do that.
So 0.1 plus 0.2 equals 0.3.
Yeah, what do you expect to see?
I would expect this to be true.
Yeah, but you select and you go ahead and it says, it fixes this mistake actually because it's saying 1. 1 is true. That's not the case in many other languages. I don't know how it's fixing that. I think it's with what I'm about to explain. So if you go to any other programming language and you try to do that, 0.1 plus 0.2 equals 0.3 is going to say false. JSFX has a fix for that, and I'm going to explain what's going on there in a minute. But if you go to like your browser and run this in JavaScript, it will say false. There is even a website for this.
Let me know if you want to commandeer the screen. We have the technology.
Oh yeah, so we don't need that, but I pasted a link for a website that explains in detail what's going on with the problem. The problem is that numbers are, in the computer, they're finite.
Okay.
And so...
Oh, is it in the comments?
It's in the comments of the stream, not the Skype
cool.
chat. So everyone can go and read that link if they're interested in the low-level details of why that fake number is a fake number and why that is important, because a fake number is fast. Okay. These are fake numbers. So you will not be going halfway, and never get there, because at some point you are going to hit the bottom of a number that the computer cannot represent. In fact, the computer cannot represent the number 0.1 in binary using floating points precisely. It loses some precision. That's why 0.1 plus 0.3 is not 0.1 plus 0.2 is not 0.3, because it loses precision along the way. And it comes out with the 0.300000004 that there is in the link that I pasted. Okay, so there won't be this issue of going halfway there and never getting there, because at some point the difference is going to be so small that it will just snap into the right place.
Cool. Gotcha.
Okay. I don't know how long that will take. It will probably not take too long because we're running this 48,000 times per second, which is a lot.
Yeah.
So it will probably reach the destination relatively quickly. Okay, but now I need to explain why my example did not work on your machine when I told you to paste it on JSFX. Okay, why is that happening? Well, this is something that you as the programmer in JSFX has been protected from, but you need to understand what this protection is. Because if you go write some C and C++, it will not be in place. You will not be protected from this, and you may run into this issue. In fact, when we start to try to convert the code that Chris writes into JSFX, the Air Windows effect, we will need to be mindful of this because he has to take care of the thing that I'm going to explain now, and we don't.
Cool.
Okay, what am I going to explain now? Well, when you have a very, very small number, like the 0.0000004 that happened in that calculation of 0.1 plus 0.2. That number is very small. When you think of this in terms of samples, if you have a sample that is 0.0000004 apart from another one, you will never be able to hear the difference.
Right.
It just doesn't matter. But if you throw these numbers at the computer and you ask the computer to calculate with these numbers, the computer is going to be like, okay, you are asking me to compute with this crazy number. I'm going to compute with this crazy number. And it's going to do that. It's going to compute with that number, that 4 at the end. It's going to be there. And it's going to try to do its best, and it's going to lose precision all over the place, and it's going to be painfully slow at that. The computer doesn't know better. You may care about this number, so it tries to do its best. But to do its best, it has to take a different path. Literally, our computers come with processors that literally in the chip, they have the algorithm to do multiplication of floating point numbers. If you multiply two numbers in floating points, it actually becomes electrons in the transistors, in the capacitors, it becomes electricity in your computer to do that computation, which I find fascinating. So that computation is actually done with electricity in the computer because it needs to happen super fast. Because you are doing trillions, gazillions of those operations every second to be able to see a stream on YouTube.
Right.
So you need to compute billions of those numbers in a microsecond. So it needs to be very fast. But when you get into this weird territory of numbers that are 0.000000004, your processor doesn't have an optimized path to do that computation. It needs to take a slower path because it's a crazy number. They don't come up that often. It doesn't make sense for Apple to spend silicon to come up with a processor to calculate that code. Okay, so it takes a slower path. Well, when you are doing computation with audio, we don't care about that precision. So ReaFIR just throws it away. And that's why 0.1 plus 0.2 equals 0.3 in ReaFIR, because it threw away that imprecision.
Very cool.
Crazy, huh? And the process of getting rid of that, I think, is called denormalization or normalization. It's one of the two, and I forget. I think it. Yeah, I think it's called denormalization. There is something about this in the JSFX documentation. I can look it up. But it is either normalizing or denormalizing these values. And that is making things faster. There is a section of the JSFX documentation about variables, special variables. And in there is a section, it is called anti-denormalization.
Anti-denormalization, okay, gotcha. Yeah, so let's play with this denormalization and then let's wrap it up. Okay? And we can deal with the other questions like stereo and multiple filters on the next stream. How about that? Sure.
And we'll just talk about clicks and ramps.
And I think just from this, I can figure out the stereo part of things. So yeah, let's talk about this and then.
Yeah, I can give you homework. I have videos about the stereo part, in my channel. You can go watch and do the stereo part on your code. I think it will not be trivial. It will be kind of interesting if you have the time to do that.
Sure.
Okay, I'll briefly go over what you need to do as a homework, but I want to finish the explanation about denormalization. Okay, so you have these very small numbers and you want to get rid of them. How does ReaFIR do that? Well, it uses noise.
Oh.
It adds the slightest amount of noise to your signal.
Like dithering.
Similar to that, yes. In Spirit, that's similar to that. You get rid of the very small details by adding noise, because the noise will be super quiet. The noise will be things like 0.000004, right? It will be very low noise. You add that small amount of noise, and of course, in some cases, it's going to compound with your crazy number. So maybe you are going to add 0.00004, which is your crazy number, and your denormalization noise will be 0.0003. You're going to end up with 0.0007. So you made things worse. But sometimes the noise will be minus 0.0007, and then it's going to cancel out and get rid of your denormals. So if your noise, it's random, on average, you're not going to hear any difference, but it's going to get rid of the crazy small values.
Very cool.
Crazy,
yeah,
huh?
Smart.
So let's play around with this, see this in action, disable the denormalization, which is something we can do, see how that plays out, and then we'll talk about the other things and wrap it up. You can hear that the baby is crying. I need to get back there. Okay, so go to an effect that you can play with. Maybe the test 111 effect. Cool. Yeah, get rid of all the code in there and just leave a sample block.
Okay.
Just want a sample block. And now I want you to make sure that this effect is not running through it. There is no audio running through it. I don't want any audio running through it, but I want the effect to be enabled. So put it on a track that has no inputs and enable it.
Okay, test with audio. I'm just going to put it on a new track. No. And I'm going to go ship leaps, and I'm going to go ship loops, and I'm going to go even ship loops, and I'm going to put it there. Okay. Here we go.
Okay. So there is no audio coming through, but the effect is enabled. So add it to the code, get rid of everything, leave the samples block there.
Okay. Zoop.
And then in our sample block, we are going to have one of those debug variables. So say debug, and then say
my God, today
plus equals
my butterfingers.
SPL0. That's our sample 0. No, don't plus 1, just SPL0.
Okay.
Yes. So now our debug variable, put the semicolon there. It's not necessary because it's the last statement, but it's a good practice. So now, what do you expect the debug variable to be?
It will be a floating point number.
Yeah, it should be 0, right? It should be 0. There is no sound coming through.
Okay, yeah.
SPL0 is always 0. So it should, debug should always be 0, right?
Yeah, minus infinity is 0, to be clear, right? 0 is 1.
No. We are talking. No, we are talking about samples. So we are talking about amplitudes, not dB.
Okay. Gotcha.
So the SPL0 is a number between -1 and 1, and it represents the position of your speaker cone.
Gotcha.
So your speaker cone is just in the middle. It's not making any sound. So SPL0 is 0. You can go to the right pane. You're going to see the number 0 there. Under SPL0, it will say 0. There is no sound coming through.
Yeah.
See? 0. So if you add a bunch of zeros together, it should be 0, right? But scroll up, and you're going to see that the debug variable...
I did see it. There it is.
It's not 0.
It's accumulating.
We are adding... So that small noise, that little noise that is doing the anti-denormalization, we are adding it up so we can see it. So SPL0 is 0. We just saw that SPL0 was 0. But when we add a bunch of zeros, we end up with something that is not zero. So I said that these were fake numbers all over the place, man. You cannot trust these numbers.
Crazy, man.
Yeah, but there is something we can do to disable this. So if you have a variable, I think it can be anywhere. I think it can even be in the sample block, but it may have to be in the init block. I don't know. Oh, yeah, it has to be in the init block. So make an init block. And then define a variable called ext for extension underscore no d norm.
Okay.
There you go, that one. Equals to 0. Oh, sorry, equals to 1. You have to set this variable to 1. That's the documentation. I'm looking at the documentation right here. Put a semicolon there, and then save this.
Do we need 2 of these or no?
No.
Shablams.
Yeah, it's a magic variable that you assign to, and then you save, and then debug is 0. It turned off the denormalization. Now, try 0.1 plus 0.2 equals 0.3 in peak. It should say false. It should say 0.
I got a quick question regarding that. The number of decimals in the floating point is the number of our bit depth, right? So bit depth is giving us like extra decimals to calculate that floating number, right?
It's not that simple. There is a relationship. Your bit depth determines how many numbers after the dot you can have, but it's not a one-to-one correspondence.
Oh, okay.
Because of the floating point representation. You can go to that link I pasted and you'll learn way more than you want about floating points.
Cool.
And then you see that the relationship is not one-to-one. Okay, so it still evaluates to 1. I have no idea what's going on there. Maybe it's not turning off the denormalization for that computation or whatever. But we saw with the debug variable that we can turn off the denormalization, which will make things slower, but it's necessary in some contexts. In some cases, like if you're trying to do something that is going to oversample like crazy to get rid of some artifacts, maybe you are going over the sampling frequency and you need to oversample and then you don't want denormalization, whatever. You can turn it off if you want.
Cool.
But things may be slower if you're not careful. So you have to, in your code, you have to denormalize in some other way, maybe by adding some small noise. And in C and C++, you have to denormalize by hand, or your effect will be slow. And I know for a fact that Chris writes some code to denormalize stuff because I read his code and he was doing that.
He's big into oversampling and stuff too. Can we maybe look at Bo's comments and then if you gotta go, we can wrap?
Yeah, so I'm guessing the clicks comes from the sound changing at a sample level. You gotta get bursts of full frequency aliasing when that happens. So if the samples change too fast, you get a blast of full frequency. I think you get just high frequencies, but I'm not sure. And aliasing is this effect when you have some signal that is so high frequency that your sample rate cannot represent it. It's above
Nyquist.
The Shannon frequency. Is it
the Nyquist?
Yeah, Nyquist frequency. Yes, Shannon is the information theory person. Yeah, Nyquist frequency.
So yeah, I think Bo, you're right.
Oh, and Bo is asking another good question here. Sorry, Bo is asking another good question here to wrap things up about Bo's question. So if you want to set it to a second, how could you do that? So I guess he's asking about if you want the target to move and then your follower to get there in 1 second. How do you do that? You do that based on the sample rate, yes. And you multiply by this small number because of...
He's taking millisecond to second? Yeah.
Milliseconds. Yeah, that's what it is. So yeah, I guess that's a reasonable way of doing it. Yes, I guess
just
you're right.
have one too many zeros. It has to be divided by 1/1000ths, not 1/10,000ths.
And I don't think you have to multiply this at all, because this S rate variable is a sample
It's
rate.
already
It's
a
48,000,
second.
for instance, and it's already a
Yeah.
second. So all you have to do is divide by the sample rate, and you'll get there in a second, I think.
Yeah. Maybe.
I'm doing mathematics off of my head here, but I think it will work.
Euler's numbers. That's something I read about like literally 3 days ago, and I can't remember because I'm old. I'm not so old, but Jesus, I used to remember everything.
Yeah, Euler's number is just a constant. It's like pi.
Oh.
But it comes from a different source. Pi comes from a circle. Euler's number comes from, I don't actually know. But it's used all over the place, and it's useful in many ways. But I don't know what Bo was talking about at that point. I missed that point. Okay, so you were going to ask a question before I interrupted you.
Yeah. Okay. So no, I was just saying that Bo is right. I think what I'm getting is like a little burst of high frequency, and that's when I generate a new question. I get it for a second. So I guess there's two things happening here when you generate a new question. The dB gain is reset, which I just learned to control, and the filter type is changed, which I guess like in a regular EQ, if you have like a low pass and you make it a high pass, it doesn't, the math of that wouldn't cause a click, right? Because the math of that,
Yeah. So we need to talk about something else here about clicks and ramps and stuff, because I explained this whole follower idea for sliders like dB gain and frequency. But what about the filter type? That is not a continuous change. That's not something you can follow.
Right.
Right? So I can imagine two solutions for this. And I'll run the ideas through you. I have never done this myself, and you see if it makes sense and which one you prefer. Idea number one is we do the ramp to slowly turn off the filter and slowly turn on the new filter.
Oh, so each filter type has its own dB gain value, and we just, okay,
Yeah, so you just ramp up the dB gain to be neutral. You ramp up the frequency to be like on a low pass, you make it 20,000. You turn off that filter slowly, and then you turn on the new filter. You crossfade the filters.
Right.
That's idea number one. Idea number two is you don't ramp dB gain and frequency. You ramp our coefficients, our A0, A1, A2, B0, B1, B2. Those are you would compute B1 target, and you would let B1 follow that. I have no idea what that will do, but I think that what it will do is it will morph one filter into the other. So your low pass will morph into a high pass. It's very cool. It's something that I learned in Ableton.
Yeah, Ableton
there is
does that.
A way there you have a continuous control between filter types.
Yeah, it's awesome.
I think that's how you do it.
I think that would
but I don't know.
my
I'm making
brain.
math here. I'm making math up here.
Yeah, I think because already, again, like this B1, A2 stuff is stuff that I copied and didn't understand. So I think for me, it's easier if just dB gain is adjusted. So each filter type gets its own dB value. So we just ramp one to 0 and ramp the other one to whatever. One thing that I'm just so the last bit of information that I would need, then I think I can make the medium for this is, so if I copy all this code, I make filter type 2 low shelf, high shelf, blah blah blah. So now I need to take filter type low shelf and add it to filter type 2 high shelf. So would I just grab one more of these and add those? Do you know what I mean? Like, do I then need a new A1, a new B1, a new B2? If that makes sense. Does that make sense?
Yeah, if you are going to have different dB gains or different frequencies, you also need different B1s and A1s and so forth, because A1 and B1 and whatnot, they are calculated based on the dB gain. So if you change dB gain, you're going to need to copy over all the variables that depend on dB gain, either directly or indirectly. In this case, A0 depends on dB gain indirectly via cos omega, beta, and so forth.
Right, fuck.
Yeah, that will balloon in size.
Yeah. Wow.
Yeah, but it's something you can do. And it actually kind of goes to the other question you had, like, what if I want multiple filters running at once? Well, to run multiple filters at once, you just have multiple filters and you apply them in series. Conceptually, it's as if you are taking this JS effects, you're putting it on the track multiple times and you're using different parameters on it. But we want to do that in a single effect. So instead, you're going to have like n, y, n, and you're going to have z, n. So you apply another filter on y to get z.
And you multiply.
And then you apply you just you pretend that your yn is the xn on the next filter.
Oh, jeez.
Yeah. So you're just chaining these filters in a row. And if you do that, you will, in effect, you will be putting multiple of these effects in a row, like you're just putting them one next to the other. So your x is your sample coming in. Well, if you want to put two filters in a row, you take the filter output, the first filter output, and you say that that is the input on the second filter, and then you chain that way.
Cool. You know, I'm already thinking of a workaround because this sounds like a nightmare. And that would be to, instead of, because the medium basically will solo a band and then it'll ask you what band it is. So I could use a band pass and then whatever's outside the band pass, just polarity, like reverse polarity out, so I don't have to write all the code twice. Maybe I'll try that. Or maybe I'll just copy.
Yeah, and you know how there are some EQs like ReaEQ that gives you an arbitrary amount of filters. You can just add bands, more filters. Yeah, bands or poles and zeros, or however you want to call them. And then there are other EQs that don't give you that. And I always found that silly, like, why can I only have 4 knobs? This is silly. This is a computer. I should have infinite knobs if I want. Well, I think that it's because the developers were copying and pasting code, and they didn't want to copy and paste more than 8 times. So they give you 8 of these bands or filters.
And I guess infinite bands when it comes to practical, like one of the things people love about FabFilter is like, bro, 24 bands, bro. I'm like, why would you need 24 bands for anything of audio? But that's a whole other thing.
Yeah. When you are being that surgical, you can just put two EQs in a row and that will work. Or better yet, go use ReaFIR, which will give you a really big number of bands. In ReaFIR, the number of bands is, I guess, the number of your block size is divided by 2. So if your block size, the sample size, the block sample size is like 4,000, you have 2,000 bands. Go to town.
And they could be in ReaFIR, they could be like 200 and 200.01. 2 different bands that you can like play with. Yeah. Cool. Okay, well, you know me. I can ask questions forever and pitch ideas to you forever. So let's call time of death on this stream.
Yeah, so let me just see if I am not missing anything. Bo says we can do Euler another time. That's the idea of with silence treatment. Some gates produce spikes of aliasing, which you can hear some of the time. Silence treatment opens and closes more slowly. Yeah, so if you're doing a gate sort of thing, you don't want to just cut the signal. You want to apply a small fade. So in effect, what you have in a gate is a gain.
Right.
You have a gain knob or slider, and you want to change that slider to 0 when the gate is closed, but you don't want that change to be instantaneous. So you can have a target follower sort of situation for that.
Cool.
And that will be your attack on the gauge. So there you go. We talked about clicks and ramps. There is this idea of a follower. We talked about stereo. Your homework is to watch my video if you have the time. It is a video about... actually, you have to search on the video descriptions. I forget when I introduced this, but I think it was very early on my series of JSFX
cool.
videos.
I think I've seen most of your later stuff, so it must be one of the earlier stuff. And my notes app just crashed, everybody, so that's awesome. So I'll just try to use my brain, yeah.
Yeah, and multiple filters you do by putting them in a row. If you want to get weird about the mathematics of it, you could design a filter with multiple poles and zeros, and then in a single filter, it would not be a bicubic filter like the one we have. We would need to look at further samples in the past, not just two samples in the past. We would need to look at further samples in the past, and then you could do whatever filtering you want with a single filter. The downside is that it's a lot slower. You have to look at further samples in the past. The design of the filter is dependent on the result you want to achieve. So that's why people use bicubic filters in a row. You cannot hear the difference. There you go.
So just to make sure I understand it, if I make a second filter, have all these values repeating one more time, you know, B0, 2B0, or YB0 and XB0, etc., then I get SPL0 and SPL1 equals to Y underscore N1 and then Y underscore N2?
No. What you do is you will have different B's and A's. And then in the section that reads yn2 equals yn1, yn1 equals yn, and yn equals a big formula, you copy and paste those three lines. Go ahead and do that right now so you don't forget. You can comment everything out if you don't want to have it later, but you copy and paste all of this. And then everywhere where you see yn, you need to come up with a new name. So you say like zn. You don't change the n, you change the y. So that's your new output in this series. And then everywhere where you see x, you change it to be y. So what you're saying is x is your input to the filter. Now your input is the output of the previous filter. And you just made up a new output, which is called z. And then you say SPL0 equals SPL1 equals zn.
Gotcha. That's cool. Lovely.
There you go.
Cool. Got you.
Are we good?
Yeah, we're good. We can call it. I'm just going to keep playing around after it's done. Thank you again, as always. Very insanely helpful. I guess there's nothing like the thing you do in... Oh, no, there is. Is it like this? Yeah. Yeah, thank you as always, Leandro. I'm glad the baby's okay and excited for tomorrow.
Yes, tomorrow we'll be recording the acoustic guitar, and I have learned how to play the song. I even did some extra homework. I recorded a whole different song. I wrote a whole different song, and I recorded a whole different song, and that will be our what is it called? The control group. Cool. That is going to be our control song. So we need to make something that sounds better than what I can do by myself. And I wrote a song about gastroenteritis because that's what the baby had. Unfortunately, it's in Portuguese because I wanted to send it to my family. And unfortunately, no one found it funny.
They saw it too soon?
Me and my wife kind of joke.
Did they think it was too soon?
I don't know. People take babies very seriously.
That's true.
So, yeah, I have a song about gastroenteritis. I'm going to show you tomorrow. But it's in Portuguese, so I have to translate the jokes. It won't be as funny. But yeah, we'll have our control song. And I think I managed the routing of the audio, so be able to record, and that will be fun.
And on Thursday, I'm actually doing something that I've never done before. I'm going to be streaming for like probably 12 hours. I'm going to do, there's a scoring competition. I'm just saying this for Bo, basically, because I think only you are watching. Yeah, I'm doing a scoring competition, and I just don't have time. I have one day off on Thursday, and it's my birthday. So I'm going to spend the whole thing on a live stream doing yeah, just scoring and seeing what happens. So excited for that. And come join me if you want.
That's your birthday gift to yourself.
Yeah, well, actually, my real birthday is tomorrow. But yeah, but
and you'll be over at my channel?
yeah.
Really? Do you want to?
No, yeah, it's okay.
Take a rain check?
No, I have to work also, so I'm just celebrating my birthday with 1 day delay and with a live stream.
Okay.
Yeah.
Well, I'll say happy birthday to you tomorrow. Thanks for having me over.
Of course.
It was a lot of fun.
See you tomorrow and see all of y'all next Tuesday.
No, you will see us on Thursday. For
yeah.
your
If anybody
stream
wants, if
Gavanza.
anybody has 12 free hours, I'll take it.
Yeah, I don't usually watch 12 hours in a row, but I do watch streams that are that long, just piecemeal.
Yeah, exactly. Yeah, it's future proofing in case I win the competition, which is less than 0.1% chance, but we'll see.
I have faith in you. All right, let's call it.
Okay, rock and roll. Adios, everybody. And time of death.